Hi, my name is Shona McBride.
My name is Alex Segura.
My name is James.
I'm Jasmin.
Welcome to the What's in Your Cupboard Recipe Finder. According to The Guardian, UK households still waste 4.5 million tonnes of food a year that could have been eaten. The Food and Agriculture Organization reports that food waste is responsible for about 8% of human-made greenhouse gas emissions. To this end, we decided to build an app to help manage your leftovers and find tasty new recipes to explore. We also added a random button for fun. We thought it would be useful to create an app that allows you to input the ingredients that you have in your cupboard or fridge. For example, potatoes, onions, and peppers, to then generate a list of recipes you could create with those ingredients. The aim of this concept was to help reduce food waste by allowing users to easily find new and creative ways to make use of these ingredients, rather than throwing them away. During the brainstorming phase of this project, we all agreed on the following points. We wanted an app that was easy to use for everyone. We wanted an app that displayed on all types of devices. We wanted some type of interesting extra. This became the random button. We also wanted users to be able to filter the results based on dietary preferences or allergies to ensure the recipes they received back matched that criteria. For example, vegan and peanut-free. This became the filter menu.
So I'm going to talk to you about the technology that we decided to use to build our app. We decided to build our app using the React framework, as it was a technology that we had most recently used in the final part of bootcamp, and therefore we felt the most comfortable using this to build our app. React is simple and therefore the code is easy to follow, and we really liked the way that React splits up the app into components. This made it much easier and simplistic to build on the app gradually and remotely. Basic components that we started with were the search results and recipe components, as well as the app component, which would house all of the other components. If I move to recipe to begin with. So this is our recipe component. The recipe component incorporated what we wanted to return from the API. We decided to keep the recipe results very simple for our app. We wanted it to be quite clean on the interface, so we decided to display easy to view cards on the screen. So we only included the title of the recipe results, the image of the recipe, and embedded in the image URL, so clickable link, so that users can click the link and go straight to the website that recipe has come from. So that's our recipe component displayed there. As you can see, very simple in order to keep all the information quite tidy on our app. And next we have the search results component. We created this component to handle the results that came back from the API call and then display them in a simple format. So therefore the recipe component was actually housed in the search results component in order to tell the results how to display on the page. So if I just scroll down there, have a look at the search results component. We also have the search component. This is creating the search text field where you can input your ingredients, and this also creates the search button, and it houses the error message that you will get if you don't type any ingredients in and press search. So here we go. You can see search is a little bit more detailed than the other two components that we've just seen. Finally, we have the app component. So app is where all the other components, obviously apart from the recipe component, come together and are displayed in the app, either initially or when they are targeted. The app also contains all the state, which was useful as we could reuse the state across multiple components. There are also two other additional components that I haven't shown you yet. So we have the filter menu component. Another technology that we decided to add to our app is to import the React Select package in order to help us build our filter menu. It is a really simple method of choosing multiple search filters at once so that a user would be able to select allergens and food preferences in order to filter their search for the recipes. So, for example, if someone wants to select a vegan option plus one of the nut allergy filters, that would make sure that recipes with those health labels would be returned. I'll move on to the filter menu component. After we built the basic components, we moved on to the filter menu component. So as you can see here, we have chosen several options for users to filter their search results by, so food preferences and allergens. Still very simple, but we imported this package. We also decided to add a random button to our app, which meant creating a new component for that. So we have the random component here, which uses math to randomly generate recipe searches. And finally, in terms of technologies used, we decided to use basic CSS to start our app. And we also used Flexbox in order to style our app as well. This allowed for simple responsiveness, so the app could be used seamlessly on multiple devices and screen sizes. Here is our app CSS, which contains the bulk of the styling. We have styling for our edamame label. We have simple styling for the imported React Select filter menu in order to change the size of it. We have styling for the random button here. The recipe styling is for the recipe cards. The search styling covers the input and the search button and the error message. And the search results has simple flex styling there.
Following the test we use Axios. Axios is a JavaScript library for making HTTP requests from Node, browser, or XML HTTP. As a model library, it's based on a Promise API, and in order to use it, we have to install it with npm, yarn, or Power. We chose Axios over Fetch because in the first place it was the request we were more familiar with since we use it in the course. Second, it's a very easy to use API and it's in a compact package. Also, Axios has some automatic functionality that was simple over Fetch, such as converting that automatically into a JSON format instead of having to tell the data to be converted and stringify as with Fetch. Additionally, Axios has an automatically function to throw very helpful errors when a request fails, thanks to Catch, and has in general wider browser support compared to Fetch. Regarding the React testing library and Just, we decided to use Just because their tests run simultaneously and it also provides good information regarding when a test fails. The React testing library renders the component and it attaches to the DOM. Therefore, we know that we are testing is actually being rendered in the DOM. We did our best writing the test for our app, though did struggle with the React testing library. We created the snapshots for all the components we tested, which was actually very useful as they allow it to see when our code was changed from the last time the test was run, and potentially point out errors when we were not aware of. In the app test, we tested to make sure that the app was being rendered in the document if it was showing up on the screen. On the filter menu test, we create dummy props and fed them into the components in the test. We also added a test ID to the actual component, so we could target this with the test to ensure that the component rendered correctly. In our recipe test, we again create dummies, props, pass it there into our test component, and then tested to ensure that the title was being rendered within the component, and it should show up with the recipe list is returned from the API. In the search component, also dummy props were passing, and we search by role in this case, which was the button. We stated that the button should exist in the document with the name of search. Finally, our search results, again tested by a test ID that we had inserted into the component.
We tried to incorporate as many agile practices as we could when we were developing this app, which started right at the beginning really when we started coming up with a list of ideas that we wanted to incorporate into the app. So we utilized Miro, which is an online ideas board that allowed us to draw out how we wanted the app to look in the end. It was quite handy because we could interact with everything everyone had done. It gave us quite a visual representation of the app, which we could then break down into components. As we were going on, we incorporated more and more agile practices. We did stand-ups every video meeting that we had just to see where everyone was up to and if they were having any issues, which also helped us to incorporate a bit of pair programming and mob programming, just because if there were issues, we'd all get together and work on it, or some of us would if others didn't have the time. We had check-ins regularly just to see where we were up to with different components of the app. and how we wanted to proceed with the app going forward. So once we'd finished our minimum viable product, which was quite basic, it was just a text box with a search button that would fire a request to an API and return recipes. Once we had accomplished that, we all got together to decide where we wanted to go. So we wanted to add a filter menu, which we managed, and a random recipe button just for fun. We had quite a few issues and challenges along the way. One of the first things we came across was connecting up our app to the API. We had some initial issues just because it was quite different from anything we'd done during the bootcamp, and it had quite specific documentation that we had to work around. It was a challenging process at the beginning. Once we did get it up and running, we also had a little bit of an issue that the standard amount of recipes it returned was only 10, which visually and also from a user experience wasn't the best amount of recipes. We wanted to add more. So we managed to increase that and get more going.
Creating a random button was one of the initial challenges that we faced. We had to figure it out how to randomize a call to an API and binding to an event called the button. The challenge began to be solved, though, thanks to one of the first not so good designs of the Axios call. And it's because of that we realized that the edamame, the API we chose, returned recipe regardless of the chosen keyword. Thanks to that, we could create an array of objects, apply the math random method, and introduce it into the URL. After that, and due to the limitations of the API, we decided to pass another math random method to the result, resulting in a very actually random code. After that, we just had to export the function, enter through the set results recipe, and as a result, we have voila, a button that is actually working.
So another issue that we had was with our filter menu. First of all, creating a multi-select filter menu and then also connecting that filter menu so it interacted with the random button. So this is the filter menu file. The API that we used had a pre-built-in health label criteria, so we decided, just for sake of ease, to select some of the more common dietary preferences and allergies, and we presented this as an array of objects. We also decided to use a package called React Select, which contained a pre-built-in drop-down menu that allowed for multiple inputs to be added. One of the issues that we had with this setup was incorporating the multi-drop-down menu. We were able to set up a single drop-down menu quite easily, but were very challenged by how to incorporate more options. We eventually figured out that we needed to map over the options. Before, it had just been receiving the objects and it didn't know what to do with those. So once we told it to look within the objects and target the specific value, it was then able to pass that on to the API. So another issue that we faced was how to tell the GET request that it might have a value being input into it, and if a value was coming in, what to do with it. So we added the value here, and we figured that we kind of needed some kind of if-else statement to tell it what to do. So we created an empty string called health labels. We then said, if there's a value, you're going to go through the value and you're going to attach this and health equals before the value. So for example, if it were dairy-free, it would attach and health equals dairy-free. We then knew that for the URL, we needed to send a URL if there was this health labels incorporated into it. And if not, then we just needed to send the regular URL. So we used a ternary to solve that issue. We said, right, if there's health labels, then we're going to stick them on the back here of the API. Otherwise, we're just going to do the regular API call. The other thing that we knew that we needed to incorporate was pretty much the same functionality into the random button. So once we'd solved it for the Axios recipe call, it was actually quite simple to incorporate this into the random. Again, we just created an empty string called health labels. We put in a value that's then passed into the if statement. And again, it just adds the and health equals prior to the value. And then within the call down below, again, we just did a ternary. We add the health labels on at the back of the first URL option. And if there is no health labels, then it's just going to be the normal URL that's being sent. And this means that that, for example, if you're clicking for a random recipe, but you know that you definitely don't want any peanuts, for example, in that, you can select peanut free and then hit the random button, and it'll only bring back recipes that don't have any peanuts in them.
Another challenge that we faced was the error message functionality. So initially we created our error message within the search component. However, we realised once we'd created a random button as well and added that to the app, that the error message would not disappear if the random button was clicked. We struggled for a while trying to figure out how to move the error message functionality into the app component so that we could use it with the random button. As the random button does not require any input, it would have led to a confusing user experience if the error message had remained in place and would not disappear. Initially, we tried adding an if-else statement to the get results function within the app, but that didn't work. Eventually, we realised that we can move all of the error message functionality from the search component into the app file and pass the necessary functionality into the search via props. This also meant that all of our state was now within the app file and could be reused among the various components.
We also had some issues with our CSS, mostly in terms of responsiveness. We first noticed it on bigger screens as we tried to build from the bottom up, where our banner was not stretching to the full size of quite a large screen. It was quite easy to fix because we just added a new media query in to allow the image to become larger than its original size. Once we'd added that in, however, there was a little bit of an issue with smaller screens in that there were a few buttons that wouldn't align properly, and they also changed size when we went down to a smaller screen. So anything below 560 pixels. And we did fix this with another media query that simply changed the flex direction once it hit 560 pixels.
If we had more time, we would have liked to have added in a login section. A user could create an account with the app, log in, and will be able to save the recipes they like it onto their profile so they could easily find them again. Will have liked to improve the search text box to be more user-friendly, because currently all the ingredients need to be entered in one line, and we will ideally have wanted something similar to the filter menu where you can add ingredients and each ingredient has its own box with an X next to it. In that way, an ingredient could be easily removed if the user did not want it, and it will also create like an easier view list for the user.